And with that, I think I'm going to bring Anya up soon. Anya, are you there?
Hello. Hi, Kevin.
Hi, Anya. How are you?
I'm good. Good.
I'm going to deeply apologize for butchering your last name. I'm so sorry.
We can set time aside next time.
We got to get you those shoes, really, is what we got to do.
That's the solution. I'll take that.
Thank you so much, Anya. And I'll leave it to you.
Thank you. Thank you, Kevin, for a great introduction and the keynote. And I'm really excited to be here and open the DataDev Day. Welcome again, everyone, and I hope you enjoy the sessions today and learn something. And with that, I'm going to start. On February 15, 2013, a small asteroid, just about 17 meters in diameter, it's quite small, which is about the size of a 6-story building, by the way, broke up over the city of Chelyabinsk in Russia. The blast was stronger than a nuclear explosion, and they triggered detections of many monitoring systems as far as Antarctica. And the asteroid came as a surprise not only to people in the region, but also to NASA. NASA has been searching for potential and tracking potentially hazardous objects for decades, but they were not looking at asteroids as small as the one that hit the Earth in 2013. They were looking at asteroids only about 140 meters in diameter. And as I mentioned, the one that hit in 2013 was just about 17 meters. So after this event in 2013, NASA established the Planetary Defense Coordination Office that takes care of all the tracking of so-called near-Earth objects, or in other words, asteroids, that are going to pass Earth within a certain distance, so they are prepared when something like that happens again. So this story is very important because it shows not only that it's important to track data, but it's also important to understand what type of data it's important to track and how frequently you should do that. So now that I got your attention, let me introduce myself. My name is Anya Prosvetova. I'm a senior data engineer at Aimpoint Digital, and I'm also Tableau Visionary and DataDev Ambassador. And today I'm going to talk about how we need to remember to look up and look at asteroids, but how we can use Tableau to make this process much easier and to track these asteroids going forward. And this presentation is going to use asteroids as an example to showcase the table extensions feature that Tableau introduced in 2022.3 version. First, we need to look at what are the table extensions. So table extensions are part of an analytics extension functionality in Tableau. We're going to look at how this functionality with analytics extensions worked before the version 22.3. And then after, when the table extensions were introduced, I'll show you a quick demo and then talk about also some potential use cases that we can use this new functionality for. And as previously, you can ask your questions in the chat, and either my colleagues or I will answer after the presentation. And also, I will be sharing this deck with you, so you will be able to go through and actually also download the workbook and see how it's built and see the code as well. So with that, let's go and start looking at what are the analytics extensions. And this feature has been around for quite a while in Tableau, and it's available in both Tableau Desktop, Tableau Server, and Tableau Online, but also in Tableau Prep. And this functionality allows you to run Python or R scripts. In this presentation, I'm going to focus on Python, but basically whatever I'm talking about today, you can also do using R as well, if it fits better your purpose, your project. And to be able to use this functionality, you will need to have either TabPy for Python or rserve for R. These are the servers that actually connect Tableau and Python or R, and allows you to run the scripts. So the script is going to be placed in Tableau, and then Tableau will send the request to TabPy or rserve, and gets the response from your code. So that's how it's going to work. We have input data. Imagine you have some data source connected in the workbook. Then we create a calculated field, like you always do in Tableau, and use a script function there. We have several options for script functions that you can create. You can create a script function that returns a Boolean value, integer, real, as it's called here, or a float, or a string, just a text value. So the function that you will select depends on what type of value, what data type of the value that you would like to return back. Then in this calculated field, once we decided which script calculation we need to use, we paste our code, Python or R, and then we can also specify which fields that we would like to use from our dataset to pass to this code. This code and these fields are going to be passed to TabPy or RServe. This is going to process them. The server outside of Tableau is going to process them. And then the data will be returned, say some kind of model, result of a model or result of a certain calculation. And then you will have this value appearing in your data visualization. So as you can see here, we are staying in the environment of Tableau Desktop. We are not creating these scripts outside. We just pasting them directly into the calculated field. And then I will show you how to set it up in Tableau Desktop. Then using the analytics extensions functionality, we can run the scripts and get the results. And the great thing about it, it's also interactive. So you can write these calculations or models and give your users the ability to tweak the parameters, change the input, change the values that they want to use, and see how the results, again, of a certain model, for example, change and what kind of results it gives them. So it's quite a flexible function. And that's an example of how it can be used. And as I said, it's very interactive functionality. So here, an example, quite simple. We have a map of the world with different countries on it. And you can see that when the user clicks on the map, at the top, the details about this country that the user is clicked on, updated, and you can see the capital for this country, the country area, and so on. And so working in the back of this map, we have a calculated field, as I told you earlier. In this case, it's not running the model, but it's connecting to an external API that takes the input from the map, whatever user clicked on, so the name of the country, and then passes this name, this string, to an external API. And then this API understands that you want to get details about, for example, China, and then sends the details back. And these details I'm presenting at the top, so the capital, the country area, and the region. And you can see here, I'm using an example of how to get data from an external API using this functionality. Frequently, when you will read or see some webinars about the analytics extensions, mostly it's talking about how to use it to run, for example, machine learning models or some kind of predictive modeling in Tableau. That's the usual use case. But I was curious how to use this actually to get more data that you don't have yet directly in Tableau Desktop. And so we can see that it works nicely. But if we look under the hood, we will see that we have to write individual calculations for one value that we want to bring back. So what I mean by that, here we have in our chart 3 different data points about the country: capital, country area, and subregion. So I have in the backend 3 different calculations, because every time I pass the value, I can bring only one type of data back. So one field brings my capital value, another country area, and the third one is subregion. So imagine if you have many different values you want to bring from an API, that can be a little bit cumbersome, difficult to maintain, and also might be very slow, because every time you click or you change the value, so you click on the map, like in this case, all these calculations, in my case 3, you can have 13, you can have 20, all these calculations will have to run at the same time. So that can be quite heavy in terms of performance. Also, as I mentioned, it's just a normal calculated field, but all the script functions work as a table calculation. So if you know about table calculations in Tableau, you will know that there are certain limitations that you can either not use table calculations in certain cases, or you have to think about how to structure your charts so the table calculation work as you expect. So this can make it a little bit more complicated to work with these script functions in Tableau. And as I said, the impact of running these calculations, especially if there are many of them, or if you have a complex code, here you can see it's quite a short code. But if you have a long code and many calculations, that can make your workbook quite slow. And so users will get a little bit annoyed at that. So this was script calculations option of analytics extensions. But in 2022.3, the table extensions feature became available. And here you will see that instead of writing a calculated field, we actually move a little bit further, a little bit higher in the hierarchy of objects in Tableau. And we start not on the worksheet, but on a data source page. So here we can see that we have, again, our input data as usual. But on the right side, we have the script window where we can paste our script that we want to run. And then the same thing happens. The code will be sent and processed by either TabPy or RServe servers. And then we get the output data, and that will create a new separate data source in your Tableau desktop, and you will be able to use it just directly in Tableau Workbook as any other data source. A little bit of a limitation for this functionality here. At the moment, you would need to have a starting data set to start working with table extensions. And again, in a minute, I will show you how exactly you can set it up in the workbook. But you can also use just a dummy table with one or a couple of values just to have something that can serve as a basis to run the script on top of it. And otherwise, the setup of TabPy or RServe is the same as for the when you use script calculations. And one more thing I wanted to mention here, that using table extensions doesn't allow you really to have the interactivity as you can have with the script calculations. Here, the main advantage is that you can bring back the whole data set, the whole table with all the values, as many fields as you want, 50 columns or something like that. You can bring the whole table back and use it as any normal data source in Tableau Desktop. So as I said, the feature is relatively new, and hopefully it will be updated soon and we will get rid of certain limitations there are. But I think it's a great start and it's a really useful feature for you to play around. And that's the time for my demo. So let's go back to Asteroids and see how I use this idea of this topic of asteroids to try out this new feature of table extensions. So here you can see my dashboard. It's quite a simple one, but the main idea is that at the top, you see the total number of asteroids that are going to pass Earth within a certain distance on a certain date. The dashboard by default shows you the period from today up to 7 days in the future. 7 days is the limit of the API, the NASA API that I'm using here. And then you can see also that asteroids are formatted based on their size. They colored based on whether NASA considers them hazardous or not. Don't worry, NASA has a lot of different definitions of what is considered hazardous. So this is more about the speed and the size of the asteroid rather than necessarily the distance that it's going to pass Earth and whether it will going to be very close or not. So now let's actually go into Tableau and see how I set it all up and how it can be built using the table extensions. So now let me share my screen. And while I'm navigating to my screen, actually, let's not go into the dashboard first, but let's look at the code just so you can understand how I'm doing it in the backend and how I'm actually getting this data. So you should be able to see my code on the screen. And at the top, we, as always, start with importing libraries that I'm going to use. And you can see this one is quite simple. It's just requests and pandas to format the data into data frame afterwards. Then I'm using my API key from the NASA API, and you can get it very easily on their website. And then I'm just setting up the period for my code. So in the code, I set it up in a way that every time you open the workbook, it by default sets the start date to today, to the day when you open in the workbook, and then pushes it to the maximum limit of the API, which is 7 days. And then I'm building my URL, the request URL that I'm going to send to the API. So you can see that I have the start date here, the end date, and then I pass in my API key. And that's my URL. I have tested it a couple of days ago. So if I rerun from this one, that should get me the new start dates, the end dates. I might need to rerun it from the beginning. But the thing will change is only the dates. Yeah, I'll need to run it from the beginning. It will be quick. So I'm importing all the libraries. I'm passing my, setting up the variable for my API key. And here we go. That should work. So I now set the start and end date. And when I update my URL, I will be able to see that it picked up today's date, which is 15th of June. And then the last day of the period will be 22nd of June. Nice. Then when we work with APIs, we need to make sure that A, the API is actually running and is there to accept our requests, and B, that we structured the URL in a way that API will understand it. So I just want to get the code, the response code, to see whether the API is still there. And the response code, for you to feel good about your process, that it's all going well, it should be 200, and we're getting it here. So 200 code means that the API is there and listening, and our URL is structured correctly, so nothing to do there. All good, we can continue. And then when we actually send our request, the response comes back from the API in the form of JSON file. You can see it here, how it's structured in the form of pairs and pair and key values. And say, for example, if I just scroll a little bit further, we have 81 elements that are brought back, so 81 asteroid basically that's brought back from the API for this period. And then you can see for every day, it shows us the details about this asteroid. They have a reference number, they have a very easy to understand name with all these numbers and digits and letters. We have the URL even to go and see more about this asteroid on the NASA website. And all we have other specifications about the API, the asteroid, like the diameter, the speed, whether it's considered potentially hazardous, close approach date, so when it's going to pass Earth, and so on. And so if I scroll further, I just see all these different asteroids. So let's not do that. What I want to do I want to just pick some of the data points that I'm interested in. So, and parse this JSON to make it a table, because you can work in Tableau with JSON files, but tables are much easier to work with, and Tableau understands them much better. So what I'm doing here, I'm just building this data frame, giving the names to the columns, and then picking the data points from the JSON file to put them in the correct column, in the correct order. That's all good. So that's my final data frame. If I scroll further, I'll need to run it. Oh, no, I need to run this again. I thought I can skip that, but no, of course not. Now, if I run it, these were the options that I need to update my code actually, but now when I run this cell, I get the final data frame. I just have 10 rows here to show you the sample. But you can see now it looks very nice and clean as a normal table with all the details that we want. with all the specifications, with all the times and measures. And then it won't work here in the Google Colab, but at the end, when you work with the analytics extensions functions in Tableau, you have to return the final output. You have to have the return statement in your code. So if I run it here, it will give me an error because for the Colab, it doesn't really make sense there is nothing to return, let's say so. But in Tableau, you will have to add the return at the end of your code to make sure that Tableau brings back the table that you created. So that's how the code works. And now let's go to Tableau. So you can see here that I last updated this workbook on 13th of June. And that's when I was doing some testing. And now we will connect to our TabPy and update the workbook so it picks today's date and then stretches the period for 7 days further. So at the moment, I don't have TabPy server running anywhere. So I will start it on my local computer. TabPy is basically a Python library that you just install as any other normal Python library on your computer or on a server where you want to run it in future. And then you can, if it's a server, you can just keep it running all the time. On my local machine, I don't want it running all the time, so I want to launch it just now for this demo. And you can see that because I have it already installed, I just need to launch it by typing TabPy in my terminal. And once it all works, I see at the end the message that tells me web service listening on port 9004. So that means that our TabPy server is up and running and we can use it. Now let's go and connect it to our Tableau dashboard, to our Tableau workbook. We don't need to verify Outlook at this moment. To connect to a server, to Python, TabPy, or RServe, in Tableau Desktop, you would need to go to Help at the top of the screen, go to Settings and Performance, and then go to Manage Analytics Extension Connection. And now, because I'm running the TabPy on my local machine, I just need to say the host name is going to be my local host and the port, as we saw in the terminal message, 9004. So I actually don't need to do anything here. Of course, if you have your personal private server with passwords and usernames, you will need to update that. I can test my connection, have a nice message saying that it's all connected and works. Great. But now I get an error that tells me, oh, something is not working. I can't really, the rows, the values that you use in your table, in your dashboard, they don't exist. Okay, I know, because we're just connecting to the TabPy, and now we need to apply the connection to the TabPy again, and then the data will be updated. This happens here because I didn't have the continuous connection to TabPy, but if you have the TabPy server running on a special dedicated server, as it recommended, you shouldn't have this issue because you will have this continuous connection. In my case, I know how to deal with that. Let's close this error. I just saved my connection. And now let's go and see how I actually set it up, and we will reapply the connection. So I go to Data Source tab, and you can see here I have my table extension, Data Source. If I open this data source, you will see that this is my dummy data set that doesn't really have anything inside, just a couple of days, just so I have a starting point. But then once I brought this CSV in, I have, as we saw on the slide earlier, I have this code window where I pasted the code that we just walked through in a minute ago. And you can see that now also the functionality has the nice code highlight, so it makes working with code in Tableau much easier. So otherwise, the code is exactly the same. The only thing that I was saying earlier is that I do have the return statement here at the end And that will be important to tell Tableau to bring back the table, the data frame. So I just click apply, and that will send the request and the code to TabPy. It will process it, connect to API, get the data back, form it as a table, and then bring it back. And you can see all my errors are gone in the lower part of the screen. And if I click update now, you will see this is my input table, which is not really special. But then I can see my output table. And that's the one that we saw as well just now in Google Colab, nicely formatted data with all the details about asteroids. And if I go back, oh, sorry, I just want to show you one thing. If I close this window, I have this table extension data source as any normal data source. And I can even bring the any other data source if I need to, and use it as any data source in Tableau. I don't need to do it. I'll bring it back. But now let's go to the dashboard, and here we go. We can see that our asteroids now are showing from 15th of June, from today. And we can see that we will be able to use the filter, the date filter, to navigate through different days. Let me bring it on big screen. And we can just flip through and see what asteroids are going to appear, how are they going to look like from the point of view whether they potentially hazardous, how big they are, how close they're going to pass Earth, and so on. You can also see some definitions from NASA because they use certain words that maybe people won't understand if they don't work with asteroids. And also you can see here, out of this period of 7 days, what are the 5 closest approaches that NASA identified? And you can see that these 5 asteroids that are going to pass very close to Earth, how big they're going to be, how fast they're going to be, and so on. And so if I publish this dashboard on Tableau server or Tableau Online, if I install my connection with TabPy server on my Tableau server, next time I open it, say 3 days from today, the TabPy will run the script and the dates will be updated and the data will be updated. So you will see the most recent details about asteroids on the dashboard. And that's how you can use table extensions to get data from an external API using Tableau Desktop and just a new table extension functionality. So this was it for the demo. I just want to get back to my slides. In a second, here we go. So now you should be able to see my slide back again. And I just wanted to give some examples of how I think this feature can be used and what kind of projects you can build with that. So first of all, I think that might be really nice to build some Tableau server or Tableau Online monitoring tools using Tableau APIs. So you can have Tableau REST API resurfacing certain data about users or projects on your Tableau server. You can also automate data dictionary using Tableau REST API and metadata API. So you can query both of these APIs directly in your workbook. You can also build nice dashboards that will help you to automate certain notifications and maybe tracking some values if you have some external APIs in your company. Instead of creating a custom API connector, you can just write script and have it inside your workbook, inside your dashboard. Also, if you're working with new data sources, say like some external APIs, so maybe some applications, third-party applications that you want to get data from and you have not worked with them before, that might be a nice option as well to build a proof of concept and see whether you're getting the data that you need, whether you are connecting to this data correctly, and so on. And so see also whether you're getting the data that you need to build the visualization that you want. So that can be a nice also use case. Of course, depending on the amount of data and depending on the frequency of refresh and depending on the complexity of your code, that might be a little bit too heavy in terms of performance if you have a lot of data that you want to bring in one go. So I would still recommend in these cases to build something outside of Tableau, like either use a Hyper API to create your Hyper extract, or maybe build a web data connector if that works better. But I think still table extensions can be a really nice use case and solve quite a lot of smaller projects, or just help you to get started with new data sources. And that was me talking about table extensions. I hope you enjoyed it and learned how you can use it to build either small projects for yourself or use it in your work day-to-day life. And these are some useful resources that you can download and read about in general, TabPy. So there is a very good documentation by Tableau. You can also learn about how to use analytics extensions in general for data science in Tableau Desktop. And there are a couple of really nice videos by Tim and Amer talking about table extensions specifically, how you can use them. And of course, I can't not mention Tableau developer program here that Kevin as well mentioned earlier. I would highly recommend, if you haven't been involved, join it and get access to a lot of resources, new events, and also great community to build your projects together. And thank you for joining my session today. I will now go into the Q&A section. But if you want, you can scan the QR code and get access to the GitHub repository where I have the slides, but also the workbook and the code, so you can play. So you can play around with it and see how you can build something on top of it as well. Thank you.
Anya, I'll play MC for you. Great job, first of all. You get a lot of great questions, and I can help filter some for you. Yeah. A lot of people are asking, do you need a collab, or can we be doing in Jupyter Notebooks, or bring your own IDE? Yes.
You can use whatever environment you want to build your code. Collab is great because for demo purposes, because you can see step by step how things are changing. But you can use whatever environment you want to build the code. Of course, once you build it, and actually that's a good point, I always recommend to test the code first outside to see whether your Python code works, and then try to embed it in Tableau. But you will need still to move your code in Tableau, inside Tableau. So there you won't be able to use, for example, Jupyter Notebooks. But yeah, to develop any environment you used to.
Thank you. Then another question, this may be a hard one and may have to go back to our side on this. Is there a secure way for APIs key instead to pass them directly into the value in the table extension script?
It's a very good question. And again, for the demo purposes for a free API, I did have my code just in the open. What you can do, I don't think you can have environment variables in Tableau at the moment, but Kevin, if you have the person I can ask this, that would be great as well to confirm. But what you can also do is that you can, instead of placing the whole code in the data source page, you can actually have your code somewhere, for example, on AWS Lambda or something like that. So on an external server with all your environment variables and everything. But then in the code here in Tableau, you just trigger the, I'm showing you, I forgot that I stopped sharing my screen. But in Tableau, you can just have a shorter code which triggers this function and then picks all the environmental variables there. So that might be an option. But I don't think that there is an option now directly in Tableau desktop to have environment variables, so you don't put the code, API.
I didn't think so either. But we can confirm that for sure.
Yeah,
I will place a follow-up on that one. Great question. Someone asked, have you connected any social media like Facebook or Twitter? I'll let you answer the question.
You can, but as far as I remember now, Twitter is charging quite a lot. So unless you really want to pay this money, it's just any other API, you can connect to them and get data that you want.
Yep. Yeah, all possible. Seen it. Tableau Public is actually a great place to go look for something like this because a lot of these social media platforms had open APIs. I'll say had. Go ahead, Anya.
Yeah, I just want to say that you cannot use table extensions at the moment on Tableau Public. You can't publish dashboards that use table extensions on Tableau Public because you cannot install TabPy on Tableau Public.
Right. I think I was just saying that there are a lot of vises on public that have social media
but they use,
influenced.
They use data.
But yeah, great point. I think we answered the question of more resources. There's definitely Anya's collected some there, and there's a few other places that will drop links for these as well. The documentation site, again, developer.tableau.com. We have a whole section of the GitHub page. In our GitHub docs page, there's a whole bunch of documentation on that as well. So I can't stress enough to go to developer.tableau.com.
Yeah, and I can also do a shameless plug of my blog where I also have a separate page. I can share it later with some useful resources, with more useful resources.
Can use TabPy on Tableau Cloud? Yes.
Yes. You cannot use it in Tableau Prep at the moment, in the combination Tableau Prep and Tableau Cloud, but you can use it in Tableau Desktop, in server or cloud.
Yeah, you can configure the server essentially in cloud to go call out to it.
Yeah.
Is Selenium library used to automate or is different? Please share some highlighted on automations.
Depends on what you mean here by automation, but Selenium library is usually used to scrape data from websites. So you can also do that. You can write the code that scrapes, say, a website and then builds a data frame and then brings it back to Tableau. You can do that. Just make sure that it's okay to scrape the website that you want to scrape. But otherwise, it's possible.
All right. What else do we got? Sorry, going through the list here, y'all. Christian is asking, Christian, who is also a DataDev Ambassador, who I'm going to pick on right now. Christian, I'm not going to answer your question about Windows. No, or just kidding. Trouble running TabPy on Windows. Could you help? Yeah, you know where to find us, Christian.
Running TabPy on Windows can be a little bit tricky. Installing it maybe, but just because it's Windows. Not to.
I didn't want to say that, but
yeah, well, I did, so you're okay. You're safe. But running it should be okay. Yeah, Christian, you know where to find me.
Just seeing a few more questions come in here. Can we build a Python script in Tableau based on multiple data sources?
So what I think you mean here, Prasad, is whether we can use Python script with different data sources. And so it either can we use different data sources in Python script to build a data source in Tableau? Yes, you can. You just say connect to 3 APIs and bring data together in your Python script and get one back. Or you can have 3 separate data sources in Tableau and then join them or build relationships as you would do in Tableau with these data sources. So that's possible as well.
We're just looking for a few more questions here, and
I see there is number 77. I kind of responded to that. Can we use it in Tableau Prep to load data to database? So if you're using Tableau Server, you can use scripts in Tableau Prep, but it's just a script step. There is a special one, so it's not going to be like what I demoed. It's a little bit more straightforward even. there's a separate
Yeah, and I
step.
think maybe third-party web services, if you're talking REST APIs, then we have a couple different options. This is totally possible, right? If you're connecting to Python, you can pull those data sources in. Or the other option is the web data connector. So you can write a connector that goes and fetches REST from REST services. Does the embedding data source? Go ahead.
Sorry. Actually, on my GitHub, so if you scan the QR code on my GitHub, there is a separate repository where I actually show how to do that in Tableau Prep. So you can have a look.
There you go. There you go. Multiple table extensions. That's a tricky one.
I guess as many as you want is just going to make the workbook slow, I guess.
Yeah. You can pull in a lot, but definitely will make the workbook slow.
Think about the performance.
Can the web data connectors be written in Python? The web data connectors are written in, we'll send you the documentation.
So wait for the session. I forgot when it is, but it's later today. Oh, that's about table extensions. Sorry. Web data connectors should be JavaScript.
I think it's Java. I think we've been playing around with web data connectors, but Christopher, we will get you an answer there.
Yeah.
Can you use Python to automate dashboard creation in different projects with different data, but all the projects have a set of standard metrics that are continually being evaluated? So Daniel asked this question. It sounds like a lot about maybe putting some source control practices into your Tableau workflows. You can. It is not greatly supported. For example, everything in Tableau, or at least the workbook, is XML based, and XML and Tableau and like altering things on like a Git, like if you check in like your code and then like go and change it and check it out, Tableau doesn't necessarily like that. This is possible. There are a few resources online that have done this. There's actually partners who've done something like this. So it's possible. It is not the most easiest thing to do, I would say. But it is possible. Also, supported is a different question too. Okay, I think we're
about embedding dashboard. It should work on browsers and regions, but you really have to test it.
Yeah, I saw that question. Saw that question about the embedding dashboards. Yeah, I don't know if our evolved is not on anymore, but yeah, it should. It's iframe. Some of it's iframe, other of it is not. So I would check out the documentation and again, test.
Yeah.
Okay, so we have thank you, Anya, first of all, so much. This was fantastic. I definitely learned something today about table extensions, and I knew the asteroid. I didn't know how large it was. So thank you.